So in this question, we're supposed to use calculus to find the approximate change in x when y is increasing from this particular value to by a small amount. So what we need to understand is that y is increasing from this point by this amount of value. So in order to work out this, we need also to remember that a small change in y over small change in x is approximately equal to dy dx. So that's actually the assumption, that is the reasoning we're going to use in this particular question. And in order to find the value of x, we need to find the value of x when y is equals to this particular value. So we need to go to the table, this one's table. We are going to go back to the table up here and check where do we have root 3 over 2, and especially when we have sine, because y was sine 5x. So which means that if you do sine x naught, sine 5x naught, we are going to get sine 5x naught x. Y we have said here, let me just go a little bit back. Y is equals to sine 5x. Okay, so which means that we need a point where we have y being equals to this value. So what is going to be the value of x for that to be root 5 over 2? So if you look at that, because we're talking about sine, then we are going to focus especially at this area, and where we have sine is this part, then we shall look at this value at that point. So where we have root 3 over 2 is when the angle is pi over 3, is pi over 3, right? So we can say from the table, sine pi over 3 is equals to root 3 over 2. Okay, yeah, so which means that we need to know x naught. So we can say sine of 5 x naught is going to give us root 3 over 2. So meaning, what should be this angle that should be here, so that it will give us pi over 3, which is equivalent to root 3 over 2. So which means that this must be what? This must be something to do with pi over 3 is equals to 5 x naught. So which means that this is going to x naught is going to be equals to pi over 15. So our x naught here is going to be pi over 15 there. Okay, all right, so which means that that's the case. Then we are going to say dy dx. We're going to do dy dx at this point. Dy dx is going to be equals to what? Dy dx, integrating differentiating this part, of course, that's going to translate to 5 cos 5x. So that is 5 cos 5x, right? Which means that we need to know dy dx at the point where x is equals to pi over 15, and that is going to translate to 5 cos 5 times pi over 15. And if you work out pi over 15 here, is going to be 5 cos over pi over 3. And if you check what is cos pi over 3, cos pi over 3 is basically a half. So we are going to say this is going to translate to 5 over 2. So that is basically the value of dy dx at this point. Then the next step here we are going to move to is to find a small change, because the question was approximate change in x when y increases from this to by a small value. So we say that small change in y over small change in x is approximately equals to dy dx. So in this case, what we are going to do is to accept and agree that we already have dy dx, and we have a small change in y, which is 0.01, so meaning that we can be able to find a small change in x. So that is going to imply that small change in y is equals to dy dx times small change in x. Do we really know the small change in x? That is exactly what we are trying to look for. So which means that in order to work out that, we shall say small change in x is basically going to be equals to small change in y times 1 over, this is basically 2.5, 1 over dy dx, and this is going to end up being 0.01 times 1 over 2.5, which is going to translate to what? 0.01 times 1 over 2.5. If you work it in a calculator, you are going to get your final answer. Oh my goodness, this not, I'm not, this non-calculator paper, so you are not supposed to be seen with a calculator. So meaning that this is exactly what you are going to get. So basically that's what you're supposed to do in that question. A few things to remind you is that remember, we are supposed to use this, you may use these values that are here, and y is increasing from root 3 over 2 by 0.01, and in order to find an approximate change in y or approximate change in x, you use small change in y over small change in x is approximately dy dx. Then if you are finding small change in y, it will be dy dx times delta x, or small change in x. And then in order to work out this, because we were told the value of x, the value of y was this, then we'll go to the table, because y is equals to sine 5x, right? Y is equals to sine 5x. So which value of cos, or which value of sine, if you find that sine, you are able to get root 3. Yeah, because this is we are talking of y is equals to sine something, sine x to get us into what? To get us into root 3 over 2. Which value of x is that? Which value of theta is that can be able to give us that particular y value? And we realize that value of theta that can give us this value here is basically the sine of pi over 3, right? So we should have here sine pi over 3, it will give us root 3 over 2. Now once you've had that, you are going to go back to the original equation that we were having here. This is sine 5x. So already we have a 5 times x. That's when we are going to get root 3 over 2. So which means, what should we have here? But we should be having pi over 3, so that sine is going to be root 3 over 2. So meaning that 5 times a given angle, we must get pi over 3, so that when we put sine pi over 3, we are going to get root 3 over 2. So what should be this angle x naught? In order for us to input into sine 5 theta to get root 3 over 2, that x naught is now going to be what? If you divide by 5 both sides, that's going to be x naught. Therefore is x naught is equals to pi over 15. So the angle that you must multiply by sine to get, you must multiply by 5, then for you to get this must be pi over 15. So we need to evaluate dy dx at pi over 15, and if you work it out, it will be 5 times pi over 15, and you get pi over 15. Of course, this guys here is going to translate to this, is going to translate to this, so that, but if you go to the table, for you to find cos pi over 3 is going to give you a half, which is well seated there. So you can be able to say, therefore 5 times a half is going to give us 5 over 2, and that is equivalent to 2.5. Now we can be able to find dx dy, and to find dx dy, we are going to use this relation, that's shape that we are having here. Dx dy is obtained from this relation, because if you have dy dx and you want to make dx dy, which is a small change in x, the subject, we are going to have this beautiful expression that we're having at this given point. So once you have gotten that, you substitute small change in y is basically 0.01, and dy dx, already we have gotten it here. So which means that if you just simplify that, we are going to get your answer being equals to 1 over 50. So if you're new to Proflan YouTube channel and you've gotten value on how to answer this particular question, consider subscribing, so that anytime I'm going to upload another tutorial, you'll be notified. See you in the next tutorial, guys. See you in the next video.